Swayam Prabha. Digital India. Educated India.
So, last class I have discussed about the multiple layer case for seismic refraction test, and I have developed the expression to determine the thickness of say k number of layers, and that was discussed for horizontal layering. Now, and then I started the incline layering derivation also. Now, today this class I will continue the derivation of the incline layering case for seismic refraction test. So, as I was discussing that how I will get the travel time for the seismic for the refraction ray, and this is all the expressions of TAC, TCD, TDE. Now, if I put these values in our expression, then TAC is Z dash divided by cos IC into VP1, then plus this is 1 by VP2, then x cos beta minus Z dash, and here I can write 2Z dash tan IC minus x sin beta tan IC, then plus 1 by VP1 into cos IC, that will be Z dash plus x sin beta. Okay. So, this one I can remove. Okay. So, this is the expression, and if I further simplify that, then I will get that this is Z dash cos IC VP1, this is also Z dash cos IC VP1. So, I can write 2 Z dash cos IC VP1 plus 1 by VP2, then x cos beta minus 2 Z dash tan IC, then minus x sin beta tan IC, then this is plus x sin beta divided by VP1 cos IC. So, these equation, all this equation, now here if I replace that my VP2, I know that sin IC, this is equal to VP1 by VP2, okay, and similarly I can write VP2, that will be equal to VP1 by sin IC, okay, VP1 by sin IC. Now, in this equation, if I replace all the VP2 by VP1 by sin IC, there is only one VP1. So, this VP1 VP2, if I replace it VP1 divided by sin IC, and then if I simplify this equation, this TR expression, the first I will replace the VP2 by VP1 divided by sin IC, and then if I simplify this, then I will get that TR, that will be equal to 2Z dash cos IC divided by VP1, 2Z dash divided by cos Z dash cos IC by VP1 plus X by VP1 into sin IC plus beta. So, how I am getting that? In this equation, I am replacing the Vp2 by Vp1 divided by sin IC. Then I will simplify this equation, and then I will get the final form of this equation for the travel time of refracted ray is 2Z dash cos IC divided by Vp1 plus X by Vp1 into sin IC plus beta. Okay. Now, one more thing I am doing here, that this is the way I have given the slope, but slope direction may change. But before the test, we do not know which one is the slope direction. Okay. So, that is also one unknown. So, slope direction is also unknown, slope angle is unknown, velocity of the two layers are unknown, thickness of the layer which is varying, that is also unknown. So, now what I will do, that I will change the position and the position of source and the position of geophone. I will interchange that. Basically, now the A will be the position of geophone and E will be the source. Okay. So, initially A was the source, E was the position of geophone. Now, A is the position of geophone, E is the source. I am interchanging their position and do the same test. If this is not a layer soil case, it is a horizontal layering. Now, both the cases I should get the same result, same data. If I change the geophone and the source position, if I interchange, for layering case, I should get the same data. But as it is incline layering, then I will get different data. Okay. So, that is why now if I change it, similarly for now this is for A as a source, A as and E which is geophone. Now, I will get TR, that is this equation 2Z double dash cos IC divided by Vp1 plus X divided by Vp1 sin IC minus beta. Now, here A as geophone position and E as source. Okay, I have interchanged this. Okay. Now, here what we are writing, that this is TRD down, this is TR up. What is the meaning of that? This is TRD means it is going towards in downward direction, and this is TR up means it is from down means it is source, it is going down, and for the up this is source, it is going up. So, that means when A as source and E as geophone position or receiver, then it is writing as TR down, and opposite one it is TR up. Okay. So, now I will here also I will use the multiple geophone data. So, here also and multiple geophone data, and every time I will interchange the position of geophone for every geophone and the source. Okay. I will interchange the position of geophone and the source. So, I will, if I draw this plot, this is my x and this is also x, this is distance, and this is my first arrival time. Here if I write TD in this axis, TU in this other axis, this is also first arrival time. Okay. This is also arrival time of the wave. Okay, but here also I will only in refraction test will only detect the first arrival time of the wave. Okay, but here this axis is TD, this is TU. Now here I will draw again. I am not giving those points, I am only drawing those lines, but the lines are coming from the points, okay, remember that. So, I am drawing this line. So, initially again it will be the slope and this is the line, and second case this is the slope and this are the line. So, that means this is my equation number 1, this is say equation number 2 and this is equation number 3. So, this one will be what? This is down, okay, this is down versus x, down versus x. So, this will be equation number 2. So, equation number 1 is same whether it is down or up. So, this one will be equation number 3, clear. So, I have drawn this chart, this is x versus TD, this is x versus TU. So, that means first portion again this is the direct ray will reach first, then the refracted rays. In down up also first the direct ray will reach first, then the refracted rays. So, from here the slope will give me 1 by Vp1, here also slope will give 1 by Vp1, but if it is the horizontal layering case, then the slope of equation 1 and equation 2 should be same. Okay, but as it is inclined layer case, this will not be same. Okay, so that's why this will may be different. So now you say that this is my MD is the slope for the equation this portion, and mu is the slope of this portion. What is MD? MD is the slope of the second portion of the TD versus distance curve, and mu is the slope of the second portion of the TU versus distance curve. Okay. So, I can write or this is say this is A, this is B, this is C, this is T. So, I can say that MD is the slope of line AB. So, MD will be what? From this is equation 2, MD is equation 2, the slope will be sin IC plus beta divided by Bpu1, and mu slope of line CD, that will be equation 3, that will be sin IC minus beta divided by Vp1. Okay. So, I can write from this here, I can write that IC will be equal to sin inverse MD into Vp1 minus beta, and from here I can write IC will be equal to sin inverse mu Vp1 plus beta. Now, if I add them, then beta will cancel. So, I will get IC is equal to half. If I add them, if I add this to IC, then I will get half sine inverse MD BP01 plus sine inverse mu BP1. And if I subtract, then the IC will cancel, there will be beta, then beta will be half sine inverse MD BP01 minus sine inverse BP01 mu. Okay, now I was talking about the direction. So from these equations, so this beta I can get, the BP1 I will get from this curve, this slope, BP1 I will get. Now MD and mu I will get from this curve. Okay, from these curves I will get BP1, MD and mu. And if I put them, I will get the beta. So beta is now known, BP1 is known. Okay, but the direction is still unknown. So direction is meant, if the beta comes positive, then the direction of sloping ground will be towards the positive x-axis, the way I have derived the equation. So this will be the, if beta comes positive, this will be the direction of the slope, because that is the way I have derived this equation. Now if beta comes negative, then the direction will be opposite. Clear? So if beta comes positive, then the direction will be same as that I have shown in this figure. If beta is negative, then the direction will be opposite. So direction now I will get, beta value I will get. Now what is the next thing? Next thing I have to determine the BP2. So BP2 is very simple. BP2 will be equal to BP1 divided by sine IC. Sine IC I will get from the equation. So I will get from here, I will get the BP2. So BP2 also known, BP1 is also known, beta is also known, beta direction is also known. Now only unknowns are Z dash and Z double dash. Okay, so to get that, what I will do, I will extend these two lines. Okay. This one say TD0, this is TU0. Okay. Now TD0, when x is equal to 0, this part will be 0. So from here I can write that my TD0 or TRD0, whatever you say, you can write. So now I am writing TZ0, that will be equal to simply 2Z dash cos IC divided by VP1. And similarly TU0, that will be 2Z double dash cos IC divided by VP1. So from here I will get Z dash is equal to half TD0 VP1 divided by cos IC, and Z double dash is equal to half TU0 VP1 divided by cos IC. Okay. Now as I mentioned that if you know the Z dash and Z double dash, then you will get the H also. If you know the beta, how you will get the H? That is, you will get, this is half TU0 BP1 divided by cos IC divided by cos beta. So now it is all the quantities are known now. So this way you will get the beta, direction of beta, BP1, BP2 and the Z dash, Z double dash or H dash, H double dash. And I have already discussed what is the difference between H dash and Z dash or H double dash and Z double dash. Okay. So, this way you will get all the required parameters. So, similar way you can, here I have used the time intercept concept. Similar way you can use the critical distance concept also, and if you use the critical distance concept for TD case, then you equate equation 1 and 2, and if you want to use the critical distance concept for TU case, then you equate equation number 1 and 3, and then you can determine the Z dash and Z double dash, or from there Z H dash H double dash, the same way I have discussed in my previous cases. So, this is the inclined layer case. Now, the next one that I will discuss. So, let me just verify that. That is half Vp1, T0, and this is U0. Okay. So, now the next case that I will discuss, that if these all the cases we have discussed that my velocity is increasing with depth, but there are different layers, and layer thickness is such that we can assume that the density of that layer is more or less constant, and the velocity of that layer is also constant, because layer thickness is not that much. So, we are assuming that this layer thickness, where within the layer velocity is same. So, velocity is changing if, or velocity changes if your layer changes. That was the case in previous, that was the condition in previous cases. So, that means each layer velocity is constant. Clear? Now, I will discuss one case that within the layer itself your velocity is changing, because layer is, it's a very layer thickness is very high. So, that within the layer your velocity is changing. Then how we will do the, I will determine the your required parameters. Remember that in the previous case within the layer velocity is constant, but here in a single layer your velocity is changing with depth. In previous case velocity is changing with depth, but as layer changes the velocity is increasing with depth, but here your velocity is increasing with depth within a layer. So, for example, suppose if this is your layer and this is a surface, if I draw the velocity versus this is depth, and the x axis is velocity. This is a velocity and this is depth, and it is following a trend. Say that initially the velocity is say v0, this is v0, after that it is changing, and it is changing with a trend like v0 plus k dash into z, where depth is z and k dash is a material constant. Okay. So, that means here your velocity is changing with depth, but in a layer. Okay. So, now how we will do that? So, that is very common for sands, gravel. Okay. So, that means here a continuous change of velocity of wave or with depth. Okay. So, and this is the trend, that way it is changing. So, the v is the velocity at any depth, and v0 is the velocity at z equal to 0 and k dash is a constant. Okay. Now what I am doing, that this single layer, I am dividing it into number of small segment. Okay. So that single layer, I am dividing it into number of small segment. So I am dividing in number of small segment, and that segment, so this is say kth segment whose velocity is, this is k minus 2, this is vk minus 1, this is vk, this is vk plus 1, this is vk plus 2, say. Okay. So that is the layer. Okay. So, and all the cases your velocity is changing with depth, so it will follow or it will move away from the or it is actually showing same so it will move away from the your normal. Okay, it will move away from the normal, all the cases, and then there will be a depth where this angle will be IC. This angle will be IC. Okay, that angle can be IC here also, anywhere. So that this will be IC. Then if this is IC, automatically it will be 90 degree. And then it will go up again. Okay. And why I have considered this is IC? Because as I mentioned, this is the based on the where you placed your geophone. Okay, so this will be IC. So suppose this is, so this angle will be IK minus 2, this angle will be IK minus 1, this angle will be IK, this angle will be IK plus 1, this angle is KIC, sorry, IC, critical angle. Then it will be move like this. Now, if this is your this is my say thickness of layer or segment del zk, this is del zk plus 1, this is del zk plus 2, del zk minus 1, like this. Now, what I am doing, that for the kth layer, okay, the travel time will be what? The travel time will be del Tk, travel time of this refracted ray, this ray. This will be del Tk will be what? Del Zk divided by Vk, and Zk is this one. So, suppose this one is Zk, this is my Zk, this one is Ik. So, this will be Zk by cos Ik. So, this will be cos Ik. Okay. Similarly, this is del Zk divided by Vk, and cos ik I can write 1 minus sin square ik. Similarly, again I can write that sin ik divided by Vk, that is equal to sin ik plus 1 divided by Vk plus 1 and so on, and that will be equal to last layer, that is sin ic, that is sin ic I can write sin ic, this is your ik, this is sin ic by Vk plus 2, and that will be sin 90 degree. Now this is, I can write V max. Why I am writing V max? This is V max because this layer will attain this much of maximum velocity, because it will not go further down. So this will be his maximum velocity, is this one, that you can say Vk plus 3 layer, whatever it is. So that will be the maximum velocity, because this layer from here, this ray will go up again. So this ray will not go further down. So that's why this will be its maximum velocity that it will achieve, this ray. So that's why I can write it is V max. So I can write that sin ik, that will be equal to Vk by Vmax. Okay, so I can write this is Vk by Vmax, sin 90 is 1. So finally, this del Tk will be equal to del Zk Vk root over 1 minus Vk by Vmax whole square. That is the travel time within that layer, that is clayette layer. Now the horizontal distance, this ray is travel within that layer, that will be del xk, that will be del zk into tan ik. So that means this is my del xk, this is del zk. So this will be del zk into tan ik. So this is the del xk, horizontal layer, that it will travel. So I should write this is del xk. Okay. So now del zk, that will be sin is Vk by Vmax, cos is root over 1 by Vk by Vmax whole square. Okay. So now the total travel time that will be equal to T for all the layers from top to the maximum depth it will achieve. Okay, so that total travel time, initially this travel time is for that particular segment of the layer. Now the total travel time from top to that maximum depth, that will be summation of say k is equal to 1 to n, and this will be del zk by Vk root over 1 by Vk by Vmax whole square. Okay. Now similarly I can write what would be the net horizontal distance. The wave will travel from top to that bottom. that will be x summation of k equal to 1 to n and this term. Okay, so that will be del zk, then Vk by Vmax root over 1 by Vk by Vmax whole square. Okay, so this way I will get the total travel time and total horizontal distance. So now I am finishing my lecture here. So next class I will start from here and I will discuss that how from here I will get the Vmax value or the Kz, because Kz is unknown, V0 is also unknown. So how I will determine all these parameters, those I will discuss in the next class. Thank you.